Good afternoon. My name is Shoma Chakravarti. I'm the worldwide technical leader for telecom at Amazon Web Services. Joining me today, Deepu, if you don't mind standing up just for a moment, principal engineer, also from the same team that I represent. Our mission, my team's mission, is to help our customers in their journey of cloud adoption. The reason we're here is because we feel that the time is right. We hear from our customers that the cloud computing platform, our cloud computing platform, is an enabler for the transformation journey that you are undertaking. And in the conversation today, I'd like to give you some concrete examples of how. So, why NFV on AWS? That's something we'll talk about in the agenda. What is the value proposition for MANO, Management and Network Orchestration? What are the building blocks on AWS? My colleague will very quickly dive into a subset of the building blocks. NFV examples, dynamic orchestration, which is a cousin to zero-touch orchestration, and a summary. I love this slide. Deepu, it came up in conversation, and I wanted to acknowledge that it may come as a surprise. Wait, NFV on AWS? Well, I'm someone who is from the telecom industry, 20 years in telco. And we came from the school of thought of building services that never failed. And alongside comes along a cloud platform provider like AWS that has built services for the philosophy of allowing our customers to fail fast and fail cheaply. And I think this is that tipping point in our industry, in the telecom industry, where these two schools of thoughts have to come together. The ability to have services at your behest that allow you to cheaply experiment, with agility, develop new services, fail cheaply, innovate. That's the kind of capability and the core value proposition of a cloud computing platform like AWS, and it's never been more applicable to the space of NFV. I cannot progress this conversation without, at least for a few minutes, acknowledging the breadth and the depth of the platform that we have. We won't have time today to talk about everything that's applicable to NFV. We'll talk about a few building blocks, and Deepu will very summarily discuss some of them. But want to take this opportunity to talk about that subset that we see our customers using for NFV-related workloads, for MANO-related workloads. First and foremost is our compute offering. It's diverse, it's rich, everything from workload optimized instance types, compute optimized, memory optimized, storage optimized, as well as now to bare metal instances, which Deepu will talk about in more detail. The ability to onboard your own armies, vendor-specific armies, public armies, private armies. Inbuilt features for auto-scaling that can be triggered by an event, triggered at the call of an API. And then serverless computing, where the service need not be aware of any infrastructure constraints. On the networking side, our computing platform provides a programmable network that can be used alongside access networks. I'll share with you some of the hybrid scenarios that our customers are working with us on. But even in the cloud plane, what we offer is a comprehensive suite of programmable networking constructs, everything from a private space, a private network, a virtual private cloud, to support for multiple network interfaces on your compute instances, elastic association and reassociation of networks, private public IP addresses. There's also the ability for dedicated and private connectivity from an on-premise environment to the AWS backbone. And of course, IPv6 support. Our storage services is one of the oldest. It's a very comprehensive suite. There are on-premise components as well that seamlessly augment on-premise storage with the cloud. The marketplace. Already we have many VNFs from the major providers and the smaller providers from the entire ecosystem present here. Commercialized VNFs available in the AWS marketplace for use, from firewalls, load balancers, SPCs, and the list is growing. We have a thriving partner ecosystem of integrators, even alternative infrastructure managers like VMware. I alluded to this. A core part of why NFV workloads are being enabled on AWS is because of our capabilities for hybrid networking with VPNs, with direct, dedicated connectivity. And then, speaking about orchestration, there are many orchestration capabilities on AWS that, especially when you think about the disaggregation of network function, the move to microservices, network slicing, become very useful for our customers to take advantage of. This includes everything from using a template-based orchestration of a multi-VNF environment for a single network service, to container support, orchestration across containers using Docker, Kubernetes. There is tooling available on the cloud computing platform, ours, that allows you to do fleet management, inventory management, state management, patch management. Most of this can be done in a hybrid environment where your fleet consists of on-premise resources as well as resources on the cloud. There's instrumentation that can be used for network intelligence use cases. If you think of the cloud as a part of your overall network, then all of that instrumentation is available for automation. And of course, there are several tools available that you can use to define policies for compliance, for security, and manage these across your hybrid fleet. In all of these sessions today, we talk about zero-touch orchestration. And what is often overlooked, but was re-emphasized in the last session, was the need for data and the need for mining insight from data. And there are several problems and opportunities in that space, but what is not in question is the need for a robust platform to be able to do everything from ingesting the data, cleaning the data, understanding the data, cataloging it, to, of course, analyzing it, processing it. And AWS provides a truly rich and comprehensive set of tools to our customers to achieve that entire pipeline of data analysis and insight. So what is the value proposition that we have been repeatedly running into with our customers for Mano across private and public cloud? And this is an illustrative example where we have customers who have network services, network functions, VNFs running in their on-premise environment. But they see true value in augmenting that, taking advantage of this pre-built, fully managed AWS backbone for capacity augmentation, for fault tolerance, and for global outreach. There is the option for direct, dedicated connectivity across these different deployments in the AWS cloud and the on-premise data centers. Currently, these are the primary use cases that we're working with our customers on in this space. And at this point, I'd like to transition to Tipu, who will dive into some of the building blocks.
Perfect. Thanks, Shoma. I'm going to just quickly go over some of the key areas that customers have asked us in their journey on the migration to the AWS platform. There's questions about the AWS platform as it relates to NFV in general. So as Shoma mentioned, we have various regions and availability zones and POPs and various other terminology. But what this doesn't show is the large ecosystem of partners that augments this, and also the hybrid deployments and the on-premises components that are surely expanding. Each one of our availability zones is a construct that we call, it's a collection of data centers. Some of these are quite large. So for example, some of our larger availability zones will have 6 data centers, and a region could have 5 availability zones. So they really vary in scale depending on what the customer demand is in that specific area. Now, in each one of these availability zones or data centers, we can orchestrate a fair amount of different platforms based on your requirements. So we'll have FPGAs, we'll have GPUs, we'll have additional new flexibility coming in, depending on what your needs are. So just on a high level, based on your images, which you can very easily import into the AWS platform, you can orchestrate them on EC2 instances and other places. Some of the most major questions that I'm asked are about the capabilities of the platform, and especially with regards to virtual machines, which is where a lot of orchestration is worked on nowadays. So I just want to highlight that there is 25 gig bandwidth. There support for all the performance things that are commonly asked for. There's SRIOV. In fact, we provide DPDK with our ENA driver. We pass through the entire pull mode driver so that you can do whatever you want, even with Open vSwitch. We have several customers who do that today. We focus quite heavily on making sure the feature sets are available. In fact, today, over 90% of our roadmap has come from direct customer asks. And so please ask us more things. We also have AVX 512 support, NUMA support, and even things like CPU pinning. We've spent a lot of time on understanding how to boost performance based on tasks requirements. And so we've become quite efficient at that. But if you want to control that yourself, that's also available. We worked with VMware to make available VMware on AWS. And that meant actually augmenting the platform to make sure that there are other capabilities. And so through that journey, we've also made available to customers bare metal hosts. And how we've done that is by offloading some of the components to Nitro cards. And so we had a company acquisition called Annapurna Labs. And so we've been working with them very effectively to offload network and block and additional services onto these ARM-based cards. And so through that, you can really get a lot of performance, a lot of dedicated resources on your own bare metal hosts, while these Nitro cards do all the rest of the overhead. Now, with regards to orchestration, many of our customers have told us they want to use containers. So we have a managed container service in ECS. We also have a managed service for Kubernetes that's currently in preview. And you can also bring your own K8s or integrate with K8s in different places, because we understand the value of hybrid deployments as well. Now, on top of that, for truly zero touch, we have a service called AWS Fargate that takes care of bringing up the VMs, bringing them down, the load balancers, everything that's needed for the task to be completed, so that you can really focus on just the task with the application or your container and not have to worry at all about the infrastructure in any way. Now, with regards to these hybrid deployments, with regards to your data centers, I think bandwidth and dedicated connectivity is really important. So we worked with many of our partners, several of them are here in this room, on making sure that this is available. We have a Direct Connect service that has dedicated bandwidth that's offered, and it comes in various different sizes. You can actually combine a bunch of these together to get the speeds that you need. We offer these in many different locations that are expanding. And I also wanted to highlight that Direct Connect actually saves money. It doesn't cost more versus our regular rates. Now, with regards to storage, I'm just going to zoom through some of this, but just want to highlight that a lot of problems that have come from customers going to large scales and needing agility on those scales are what these services are meant to solve, those sort of problems. So we have Amazon EFS as a self-managed service that just makes available to you an NFS v4 compliant mount point. So you can have POSIX compliant storage that can scale across thousands of virtual machines as per your requirements. And then the bandwidths and the various things that come associated with the file system can also expand elastically. And the same is the principle with Amazon EBS. This block store, POSIX compliant block store that's connected to your instances, it's capable of 20,000 IOPS or more per instance, with those rates ever expanding. And anytime that you need to change the size, the IOPS, anything to do with that block storage, you can just do it on the fly. It's a single API action to just change it in live modification. In addition to that, we also have lifecycle in storage. So for blob type storage, many of our customers use Amazon S3 for lots of large bulk storage. This can be then, as part of our lifecycle management, transferred onto reduced redundancy storage, which costs less, and then for long-time archival onto Glacier as well, which is one of our cheapest storage services. Now, I also want to highlight to you CloudFormation, and if you're not familiar with it, CloudFormation is our service that really is built for orchestration and for automation. So it allows you to templatize everything that you need in terms of AWS resources into a single template. CloudFormation also integrates with many other third-party tools, such as even OpenStack Heat, and it allows you to deploy things in a region with just rapidly. You don't need to figure out the components. There's also a design aid for this. Now, why this becomes important, especially in the case of Mono, is you can very quickly create a template that has all the pieces that you need for setting up OSM on AWS EC2, and with one click, you can simply deploy it, and you should be set. And the best thing is you can also use CloudFormation to edit it and modify it in time. Now, earlier on, Shin mentioned automation, and I think this is something that's very near and dear to our heart. We work with a lot of customers on DevOps and on automation. We've learned many lessons in our journey in Amazon and retail through this, and so a lot of the services that we have internally were improved and modified, made available to customers and the general public for the purpose of DevOps. So we have pipeline services, deployment, repositories, and all of these integrate with the other third-party popular tools that you're used to using as well. So all of this is to really give you agility, to make sure that you can deploy on our platform, and even on premises for hybrid deployments. And so most of these services also support on premises as well. All right, so I'll hand it back to Shoma.
Thank you. Thank you, Deep. We want to share with you some real-world examples of VNF's network services running on AWS, and also sort of share with you the architectures at play for dynamic orchestration and some design patterns available. This is an example of a multi-VNF network service that's running on AWS. It takes advantage of a private network, a private subnet, a public subnet, takes advantage of auto-scaling, takes advantage of some partner marketplace armies, and it has inbuilt instrumentation. The dynamic aspect to this network service is that based on the instrumentation, which is provided as part of the AWS computing platform through the CloudWatch service, we can trigger events in Lambda, essentially functions that in return, based on a policy, can call other AWS APIs. These APIs may be notification. They could be active APIs in the sense they could cause routing decisions. They could cause capacity-related decisions. So this is one example. There's also a load balancing element here. Wanted to share with you that this kind of capability is very easily integrated with a Mano application or a Mano framework. Here's another example of a rather complex network core functionality that's deployed on AWS. This is the VEPC. In this particular scenario, it's a hybrid deployment with the serving gateway in the on-premise environment connected to the access network, but with the other components on the AWS cloud. We're seeing all types of variations of core network elements being deployed on AWS. This is a design pattern that has applicability when we talk about dynamic orchestration. This is just one example of how services in AWS are chained to provide the capability for a rule-based action, which is the heart of any orchestration. So in this particular scenario, this is an example. There are numerous such examples. We're just showing how during a scaling out event, automatically the DNS service is updated to include the IP addresses of the additional hosts that were added to the auto-scaling group. Data insight-driven orchestration. It's not as easy to derive insight from data, especially in the case of telecom networks. Ironically, telcos are rich with access to data. So this combination really lends itself well, and we're seeing our customers take advantage of our data analytics, data ingestion, data cleansing, data pipelining capabilities to really derive insight from their data. And then finally, I want to close with a direction that we're seeing the industry taking, which is for beyond just passive data insight-driven decision-making, we're seeing openness and adoption of machine learning and model training to drive orchestration decision-making. And here is a simple illustration of our ML stack, our AI ML stack. It includes a multitude of services with varying autonomy to the customer. So you can bring your own models. You can run it on an Apache MXNet container or Spark or Hadoop, or you can abstract to the usage of pre-built Amazon AI and machine learning services like image recognition, like text-to-speech translation, like natural language processing. And we are seeing the combination of these rich capabilities with orchestration-related policies and actions. And that's the direction we think zero-touch orchestration will ultimately lead us to. I do want to reference some other discussions that took place earlier in the morning, which were about the edge cloud and about the power of the edge in the case of certain applications and scenarios. And I just wanted to share that that's a sentiment that we share, that AWS shares. And we have, in fact, services that run at the edge. We have a number of services that run at the edge. One of them that I wanted to share in the context of AI ML-driven orchestration was Amazon Greengrass. So in this particular example, what I'm trying to illustrate is the fact that a machine learning model can be trained on the cloud with data that has been instrumented in the EMS. But that trained model has an inference module that our SageMaker product allows you to deploy at the edge. And that inference module can run on green grass and apply edge intelligence. Examples of use cases where customers are using this include immediate action in the case of anomaly detection, or data filtering to comply with sovereignty requirements. Also, security and network optimization related use cases. This is just a snapshot of our efforts working with the OSM Manu team and installing and making the Manu framework interoperable with the AWS platform. In summary, I just wanted to say that the Manu working groups all have the charter to provide this full life cycle management, agility, and control in a hybrid environment, and where we see our platform adding value to our customers is in supporting these efforts, providing innovation, agility, low-cost resources for experimentation, but also the full AWS backbone available for use for augmentation, capacity, burst, fault tolerance, and even in some cases for global outreach. That's about it. We'll be happy to take questions offline. Thank you.